Hello everyone, I'm Mr. Furlong, and today we're going to talk chemical reactions. Chemical reactions are all around us. Some of the best ones, though, take place on the 4th of July. Every single time one of those fireworks goes off, a chemical reaction is taking place. And a little side note, one of the things the Furlong family does on 4th of July when we see the fireworks go off is we try to figure out what elements are present in that firework that cause those particular colors. We'll talk about that a little bit later. Today we're looking at this idea of chemical reactions. A chemical reaction is a change in which one or more substances are converted into a new substance. So it has all new physical properties at this point. Now here's an example of one. If we take 6 molecules of carbon dioxide and 6 molecules of water, and actually plants do this, they make a molecule of sugar, C6H12O6, and 6 molecules of oxygen. This is an example of a chemical reaction that has taken place. When we do these chemical reactions, we have to keep a law in mind. This is the law of conservation of mass that says that matter cannot be created or destroyed. So we have to be very careful that when we are writing chemical reactions that we are obeying this law. So let's look at an example here. Mercury 2 oxide can be broken down into oxygen and mercury. Now let's say we had 10 grams of mercury 2 oxide. What we're going to end up with is 0.7 grams of oxygen and 9.3 grams of mercury. Notice the 0.7 and the 9.3 grams, they add up to 10 grams. Although this molecule, mercury oxide, broke down into oxygen and mercury, the total mass did not change. We had 10 grams before the reaction, we have 10 grams after the reaction. Let's take a look at this reaction. Mercury oxide is HgO. It breaks down into mercury and oxygen. Mercury is Hg, oxygen is a diatomic atom, so that's O2. How many atoms of each element is present? So if I count, there's 1 mercury and 1 oxygen. On this side, let's write that down. On this side there's 1 mercury, but there's 2 oxygens. Well, now this breaks the law of conservation of mass, doesn't it? Because we have to have the same number of atoms on each side of that arrow, or what's called the yield sign. So we have to keep that in mind when we write equations. To write a chemical equation, which is a way that we describe a chemical reaction using symbols. So let's go back to our example. So let's break this down. The compounds that are to the left of the arrow, those are known as the reactants. So these are the ones that we start with in a chemical reaction. Notice you see a plus sign between those. That tells us that we have, in this case, 2 different molecules that are going to be combined together. The arrow is called the yield sign. And then what is made are the products. So how we would read this, we would say 6CO2 plus 6H2O yields C6H12O6 plus 6O2. Let's break this down. First of all, if we see a number in front of the molecules, that tells us how many molecules we have. So for instance, we have 2 sodium hydroxides, 2 sodium chlorides. If there is no number, then it's just a 1. So for instance, with the nickel chloride, there's no number in front of there, so we just assume that there's only 1 nickel chloride compound. So that's the basic breakdown of a chemical reaction and how we write chemical reactions. We're going to be looking at how do we figure out what numbers go in front of all those compounds in another video. And I can't wait to tell you all about it.